Mineral characteristics. So a mineral is a naturally occurring inorganic solid with a specific mineral composition and a definite crystalline structure. So Earth's crust has about 3,000 different minerals in it. Minerals form rocks and shape the Earth's surface, and then some minerals have changed history, like tools made from iron. So learning how to extract iron from iron ores, for example, so that we can make iron tools. So first, naturally occurring and inorganic. So these are formed by natural processes. So we can make things that are technically minerals in the lab, but if it's made in a lab, it's not a mineral, it's a synthetic mineral. So synthetic diamonds, for example, and other man-made substances are not minerals, even though they may appear to be minerals. All minerals are inorganic, which means they have no carbon in them. Okay, so minerals are inorganic, and organic stuff comes from living things. So it's not alive. It was never alive, and it's not produced by living things. So for example, salt is a mineral because salt is just sodium chloride. It's not organic, even though organisms do use it. It's not an organic chemical. Sugar, on the other hand, is not, because one of our basic sugars is glucose, which is C6H12O6, which is obviously organic because it's got carbon in it. Coal is also not a mineral because coal was formed from partially decomposed plant remains. So minerals also have a definite crystalline structure. So atoms in minerals are arranged in regular repeating geometric patterns. So this forms a crystal. Now, a lot of times we think of crystals and we think of crystals, like quartz crystals. We think of like mysticism and things like that and think about crystals. But crystal really has a more generic meaning in that it is a solid in which the atoms are arranged in repeating patterns. So that's all a crystal is. So yes, quartz crystals are crystals, but salt crystals are also crystals. This is an example of a diagram of a salt crystal. So these can form large, well-defined crystals if they form in an open space. So the big key here is if you want big crystals, they have to form in an open space. However, it's much more common for minerals to form in confined spaces, resulting in smaller crystals that grow together. So you end up with a bunch of crystals kind of growing together instead of growing into these large crystals. Now, minerals are also solids with specific compositions. So solids have a definite volume and a definite shape. So no gas or liquid is considered a mineral. So no gases, no liquids are considered minerals. So each mineral has a unique chemical composition. So this may be specific, or it may also vary within a set range. So a few minerals are single elements. So you have things like copper and silver and gold and carbon and sulfur that can be minerals. These are what we call actually native elements. We'll talk about that later. But they are considered minerals. Most minerals are also what we call compounds. And if we remember, compounds are basically a substance made of two or more elements in a specific ratio. So quartz, for example, is silicon dioxide. Pyrite is iron 4 sulfide. Okay, so these have very specific chemical compositions. So some variations in composition. So in some minerals, chemical composition can change slightly depending on the temperature at which the crystals or the mineral crystallizes. So the main elements and crystal structure remain consistent, but there are some elements that can be swapped out or in slightly different ratios. Feldspars. So our group of feldspars are a classic example of this. So our plagioclase feldspars are aluminum silicate minerals. And that's one example. So at high temperatures, it forms a calcium-rich anorthite. Okay, so these are calcium-rich. At low temperatures, it forms a sodium-rich albite. Okay, and then at intermediate temperatures, it may contain both calcium and sodium. So at high temperatures, you end up with calcium. At lower temperatures, we end up with sodium. And anywhere in between, we can have some intermediate between these two extremes. Different appearances are due to different chemical compositions and growth patterns of the crystals. So we can have some variation in our composition, but not a lot. So our feldspars here are plagioclase feldspars. At our low temperatures, again, we get a lot of sodium. We get albite, which kind of looks like this. These two are intermediate. This would be more sodium, less calcium. This would be more calcium, less sodium. And then we get up to our anorthite, which is calcium. And again, you have the aluminum, silicon, and oxygen in here. So it's an aluminum silicate. So it has that in common. So all of these have aluminum, silicon, and oxygen in them. It's just the amount of sodium and calcium that is changing. Okay, so now to summarize some of these mineral characteristics. So first off, coal. So coal, is it inorganic? No. So coal is not a mineral. Brass. So brass, it is inorganic, but does it occur naturally? No. So brass is not a mineral. Obsidian, is it inorganic? Yes. Does it occur naturally? Yes. Is it a crystalline solid? No. Obsidian is volcanic glass. It cools too quickly. There are no crystals, so it's not crystalline. Basalt, okay, type of volcanic rock. So is it inorganic? Yes. Does it occur naturally? Yes. Is it a crystalline solid? Yes. Does it have a consistent chemical composition? No. So basalt is not a mineral. Now fluorite. Fluorite, is it inorganic? Yes. Does it occur naturally? Yes. Is it a crystalline solid? Yes. And does it have a consistent chemical composition? Yes, it is calcium fluoride. Okay, so again, to be a mineral, it has to be inorganic, has to occur naturally, has to be a crystalline solid, and it has to have a consistent chemical composition.